Ah, yes, earthquakes and Schumann resonances. There's been some science coming out about Schumann resonances and earthquakes. So, we've been looking into it. And yes, there is some interesting science, but as suspected, it does not appear to be a predictor. Now, we like to use a global incident map, quakes.globalincidentmap.com, but once again, we have so many quakes that we're only getting 2 or 3 hours worth. So, anyway, so we went to USGS and we went back to find the most recent large quake or any correlations, right? So we go to, not those. Wait, I think it is those. Yeah, so we noticed at 2005 Universal Time, as well as 2009 Universal Time, we had a Papua New Guinea quake and a Carlsberg Ridge quake. So only 4 minutes apart, and here's the Carlsberg Ridge one. All right. And we were interested in the Schumann resonances, so took a look at the Schumann resonance. In fact, we downloaded the Schumann resonance so we can zoom on it. And as suspected, there is a spike there at that time. See, there you go. 3/12/2018. There's a big spike, and I'm going to let this line here cover it up. Right at that moment, is that a predictive signal? Anyway, we have significant perturbations in the Schumann resonance at the same time as those quakes, but it's only those quakes. It's not the rest of them. So, yeah. Now, in the meantime, your GOES X-ray flux is still flatlined. We've got some choppy signals in the phi angle and the BTBZ. That looks like a coronal hole to me, especially the phi angle. It's just a weak coronal hole field. Coronal hole wind speed looks like it's plateaued. Density is pretty flat, but we've got a huge magnetometer spike. You know, a downward spike. That's a really steep spike there. And so that's very interesting. And the KP is kind of fluctuating now. So we're up to a KP at 2. Keeping an eye on that. Electron flux looks like a roller coaster. And it looks like it's going off of a cliff. So magnetometer and electron flux are going to drop off at the same time. And now the F2 layer is looking highly charged. So it's fluxed from a state of this morning being very lightly charged to now being heavily charged. I mean, if you watch the video from this morning, that's a lot different than how it looked earlier. Also, in terms of the geospace magnetic perturbation predictions, we got significant magnetic perturbations in our forecast. Let that play through. Oh yeah, great. So you see there's big fields growing there. Just keep in mind, there's more to it than when the sun is charging. You know, There's times when the sun is not charging and you have a major discharge happening at the same time. Because as this rotation happens, you have a current coming in on the one side and going out on the other side. In on the one side, out on the other side. When the fields get weak, you may have a major outflow. You may have a major inflow. That's why we look at the data. Anyway, we have noticed the issues with the Schumann resonance, and we are looking at it. Still not convinced it's a predictor, but it is interesting.